And with that, I think, why don't we get started? So I'm happy to introduce myself first. My name is Sandy Martin. I am with the Muskoka Community Land Trust, and this is the first, not the only, part of our research series. We're trying to provide information about all types of things related to non-market community wealth, housing, climate resilience, all sorts of things. So I had hoped to have an announcement of who our next speaker was going to be, which we're planning this one for January. But I have a couple of people. We're just trying to work out timelines. So I do not have that announcement, but we will make it public as soon as it is booked and firm. With that, I would love to introduce you now to Patrick Chouinard. Patrick is from Element 5. He's going to give you a much better explanation of what that is. But I've known Patrick now for a good number of months. We've worked closely on a couple of things, and I've always appreciated his direct, common sense approach to all things building technology. So with that, I'm going to mute myself, pass it over to you, Patrick. Thank you so much for being here.
Great. Thank you, Sandy. And thank you to Muskoka Community Land Trust for the opportunity to present today. And hello to everyone who has joined us. So thank you for joining me today. Quick introduction to Element 5. We are a large, highly automated mass timber manufacturer in St. Thomas, Ontario. We make two mass timber products. One is called cross-laminated timber, or CLT, and the other is called glued laminated timber, or GLT. And as a company, we provide an array of services to help hold construction projects from very early stage design all the way through to building occupancy. We are an Ontario company. In fact, I started this company from Bracebridge. I live in Bracebridge now. And we source the majority of our wood from Ontario forests and FSC certified forests. Most of the wood comes from Northern Ontario. The company was founded in 2015, and I started the company because I saw a trend in the industry towards the off-site manufacture of buildings. We live in a world of IKEA, and like IKEA, we are manufacturing buildings in a factory and shipping them to site where they are assembled rather than constructed in the traditional sense. And we are one of the leaders in this form of construction in Ontario. The motivation for the company is, one, as an entrepreneur, I saw sort of a great business opportunity, but the motivation is also about the environment and community. I saw this as an opportunity to revolutionize the construction industry towards off-site manufacture of buildings, to use more sustainable forms of construction using wood versus concrete and steel, to help overcome climate change using materials that sequester rather than store carbon, unlike the concrete and steel industries that are spewing all of this carbon dioxide into the atmosphere. We're in fact using our forests to instead remove the carbon dioxide from the atmosphere and store it in the form of these lovely buildings. And also for communities. I wanted to create healthier living, working, and educating environments for communities and future generations. So the two main products that we make, these are called mass timber products. We make cross-laminated timber, or CLT. These are massive solid wood panels. We make a wooden panel that's up to 11.5 feet wide by 53 feet in length and up to 15 inches thick. And these are considered an environmentally friendly alternative to concrete. And then on the right, we make glued laminated timber. So these are laminated members that we use to make columns and beams for buildings. And those two components combined form the skeletal structure for mass timber buildings. So on the left-hand side, you'll see a post and beam structure. And here you're seeing these solid glued laminated columns and beams, and then we're using these massive CLT panels for the floors. The building in the middle is called a CLT panel structure, and instead of using glue lam for columns and beams, we're just using the CLT panels both vertically and horizontally to form the structure of the buildings. And we're often seeing a lot of hybrids in the industry as well. So instead of glue lam columns and beams, you'll see this is steel columns and beams, but CLT panels are used for the floor structure. Even though the European market is 35 years ahead of Ontario using mass timber, Ontario is incredibly well positioned to become the center of the mass timber industry on a global basis. And Ontario's taken up mass timber in a big way. This is just a small selection of a number of the buildings in and around the city of Toronto that are in various stages of design, development, and completion. Pretty much every college and university in the province of Ontario is building a mass timber academic building. And today, we can build these buildings in Ontario up to 12 stories. And as of January 1, we can build these buildings up to 18 stories. We are currently experiencing a housing crisis in Canada, as you may be aware. It's all over the news, obviously. And CMHC, the Canada Mortgage and Housing Corporation, says that we will need 3.5 million additional housing units by 2030. This is in addition to what is already slated for construction. Right now, we are experiencing record high demand for housing, however, record low supply, making it harder for Canadians to afford suitable housing. And then there's a lot of microeconomic factors that are in play at the moment. Very high cost of construction, labor shortages, high interest rates, government fees, and a ton of red tape. We view the housing crisis as fundamentally a supply problem. Demand exceeds supply, which is driving up the cost of construction. And our approach is to tackle the supply side of the problem. And our focus is on investing in innovation, investing in technology, and figuring out how we can start manufacturing housing in factories and in volume. So as element 5, this is our, at least partial solution to the affordable housing crisis. So about 4 years ago, we decided to dedicate some resource to using this wonderful factory we have to try to help overcome the affordable housing crisis. And the thinking there was that we design and engineer a replicable kit of parts that we can adapt to unique requirements, but essentially we're using the same architecture, the same engineering, the same components, the same connection details, and we're delivering the same building over and over again. So the idea of mass customization and replicability. So 4 years ago, that was just a theoretical concept, and we've been quite successful over the last 4 years. So in 4 years, we have delivered 10 affordable housing projects in different locations, and we have a ton of others that we're currently working on. And so we've been able to use this offsite manufacturing really to help overcome at least a portion of the affordable housing crisis. Most of the buildings that we're doing today are supportive housing to help people at risk of homelessness. And that's partly because that's where we see the greatest need in the industry, but we're also using it for market rate housing and other larger buildings. So I'll just touch upon some of the ones that we've done so far. This one on the top left-hand side, this was our first building. This was for the YWCA in Kitchener. And this was for single women at risk of homelessness. The second building we did was almost exactly the same building, but 2 stories versus 4. But this one was for men at risk of homelessness in York Region, north end of Toronto. The third one was, again, for the YWCA, but this was for single women with children. So we designed this as 2-bedroom units, smaller footprint, only 3 stories versus 4 stories. And then we've recently done a few hybrid buildings, the one on the top left and the one on the bottom, at the top right and the one on the bottom left. I'll go into a little bit more detail there later. This is a 6-story version we just completed in Hamilton for City Housing Hamilton, designed to passive house standard. The one on the bottom right is one we're doing in the city of Toronto, and it's transition housing for Indigenous women. Just a few more. I won't talk about all of these. We're doing an 8-story version in the city of Toronto. We just did 5 buildings in Colorado as student residences. You may be interested in this one. This is one we're doing in Sudbury right now. We're actually delivering this building this month. It's a 5-story version of this building. The 2 that you see on the right-hand side, we finally convinced the city of Toronto to start thinking about off-site manufactured mass timber modular housing as a potential cure to the affordable housing crisis that the city of Toronto is experiencing. And we just have these 2 buildings right now that are in various stages of design and development. So this is the first building that we did, and this is for the YWCA in Kitchener. This is the completed building, and it's 23,000 square feet. It's 4 stories, and it has 41 apartment units in it. The way this project came out to tender was design build as opposed to design bid build. The traditional way that buildings like this come out to tender is a municipal government or a nonprofit housing organization or a developer will first design and engineer a building, then they'll put it out to tender, and then basically everybody has to bid on that building as designed. But this one came out to market as design build. So what the YWCA did is they just said, here's the amount of money that we have to build this, here's the piece of property. And they sent it out to tender so that various organizations could put together a team to bid on this. And this is how we were able to suggest a non-traditional, innovative way of doing this project. And so if you're thinking of, or you're in a position to go out to tender in your municipal government jurisdiction, then I highly recommend that you take a design build approach rather than a design bid build approach. And that way you'll have a number of different people's bidding different structural solutions. And that way you'll get, more innovative solutions to your housing problem in your local community. So this is the structure of that first YWCA building. We manufacture all of the components that you see here. So in this case, we're using CLT, cross-laminated timber panels for the floors, for the roof structure, for the demising walls between the apartment units, for the elevator shaft, for the stairwells, and even these exterior wall panels. All of the windows and door openings that you see here, all of these penetrations for mechanical systems are all prefabricated in our factory, and we ship these components to site like IKEA furniture, where these buildings are assembled rather than constructed in the traditional sense. This panel that you see on the outside of the building, that is one solid wood panel. It's about 10 feet wide by about 45 feet tall. So to demonstrate the speed with which we were able to assemble these buildings, we put a time-lapse camera on an adjacent building, and we recorded this video here, and I will play this for you now. Let me just check the volume. Yes, volume is down. It's only about 2 minutes, so bear with me. Let me play this for you. So again, this is for the YWCA in Kitchener, Ontario. 41 apartment units. So this is August of 2021. So the general contractor is doing all the site work, putting the foundation in place. This is before we as a company arrive on site. So this is day one, September 23rd. This is the first day that our CLT products arrive on site. So here we are. This is day 8. So within 8 days, we're able to assemble 2 floors of the building. So here we are in day 20. So within only 20 working days, we were able to assemble the superstructure of the building. This building came out and it was financed partly by the federal government's Rapid Housing Initiative. And the stipulation of that was that to receive funds, you had to be occupied in the building within 12 months of receiving the funds. So when we proposed this as a design build solution, we had no drawings for this building at all. We had some sort of renderings of what this building could look like. And from that point until occupancy was only 1 year. So this building came together incredibly quickly. And the way we were able to do that was with the team that we put together. We met on a weekly basis. Every week we met from early stage design, every week all the way through until the occupancy of the building. I don't know the makeup of the people who are here, whether you're got some architectural background or engineering background, but I'll just talk a little bit about the more technical aspects of this without going into too much detail. But when you're designing a mass timber building, it's really important to design it as mass timber from the beginning, rather than just somebody giving us a set of drawings for a concrete building and just converting it to wood. It's the process has to start early on. And so this is your typical floor plan. This is the floor plan for their YWCA building. And the yellow here indicates our CLT panels. So that's one CLT panel that spans 2 apartment units. And this building is under 6 stories, so it has a 1-hour fire rating. And when we're designing these buildings, what we're trying to do is to reduce the volume of wood in this in order to reduce the overall cost of construction. And in a 2-span continuous situation where these panels span 2 units, we can span up to 6.1 meters. So that means that the distance between these black lines is 6.1 meters. And in that situation, we can supply a CLT panel that's 175 millimeters thick. If you increase the distance between these black lines, then we have to jump up to a 7-ply panel at 245 millimeters thick. And that means a lot more wood, and that means an increase in cost. So we're trying to reduce this to 175 millimeters. So most of the affordable housing buildings that we're doing are confined to a 6.1 grid pattern. And so here we see your sort of typical 3-bedroom unit where you see these red arrows. That's where you have a structural wall. The gray area is where the panel spans, across the entire length of this unit. There's really no limit on how wide you can go. So, if you want a bigger unit, like a 4 and 5 bedroom, you can simply, break open into the neighboring bay here and just put bedrooms and bathrooms, in the adjacent bay. And there's really no distance on or limit on how deep you can go with these buildings as well. When we make a panel, the smallest width panel we can make is 2.4 meters, the widest is 3.1. So ideally, you want a panel to be between 2.4 meters wide and 3.1 meters wide to reduce the amount of waste. So buildings don't need to be simple rectangles. In this case, we have a C-shaped building, and here you'll see that there's a 6.1 meter grid pattern, and the panels are spanning in the east-west direction. If you need to create an L shape or a C shape and you need to go in the opposite direction, you simply need to rotate the grid. So you'll now see 6.1 meters in the up and down direction, and then the panels will span in the up and down direction, and same thing on the next corner. Just a couple more slides on some of the technical aspects for those of you who may be interested. It's simple ways to achieve your STC and IIC ratings for acoustic performance. And typically we just take our CLT panel and we will apply an acoustic membrane on top of it. Then typically there's an 1.5 inch gypcrete that goes on top of that. If you want to increase your STC and IIC ratings, all you do is simply increase the thickness of the membrane and increase the the gypcrete layer on that as well. So you might want to do that in a high-end condo, for example, where you want to have better sound quality. All of these, and going back to this one, most of the units that we're designing, we're exposing the ceilings in these units here. Biophilic research has shown that by exposing occupants to natural elements, we're creating healthier environments for people. So we try to expose as much wood as we're permitted. And this is what the lobby of the building will look like. So you'll see the underside of the beautiful CLT panels. Here you'll see some glulam columns and beams. This is what the hallways look like. And then these panels are fire rated. So, 1-hour fire rating situation, we can get away with a 5-ply 175 millimeter panel. So we can by far exceed the 60 minutes here, up to 96 minutes. And in a 2-hour fire rating situation, so for buildings above 6 stories, we can easily achieve a 2-hour fire rating with a 245 millimeter panel, but still leave all of the ceilings exposed in the units. So enough about the technical side for now. Despite the 6.1 meter parameter that we try to work within. These are typical adaptable unit layouts that we see in our buildings. So you can do studios, 1 bedrooms, 1 bedroom barrier free, 2 bedrooms, 2 bedroom barrier free, 3 bedrooms and beyond. The buildings don't need to be limited to a simple rectangle. You can change the size of the footprint, increase the number of floors, and they can be C-shaped, L-shaped, as you see here. This is just a few examples of the kinds of buildings we're doing today. As we got into this, we came across developers who were used to working with light wood frame materials, doing the entire building out of light wood frame materials. And then they were interested enough to test the waters and see what it would be like to start using CLT for just the floors and the cores of the building. So instead of doing the whole structure of the building, they're doing the building in these light wood frame panels that are made by independent third parties. And they're just using the CLT floors and cores. So here you'll see the underside of the CLT panels in this room here. And the first building that we did for them, by using CLT panels for the floors, they shaved 5 weeks off the construction schedule. And you can imagine these panels in this building are about 10 feet wide by 40 feet in length, and dropping these large panels into place, how quickly that building assembles versus, using traditional I-joists. And in addition to that, these panels are fire rated. So in order to achieve fire separation with I-joists, you have to insulate between the I-joists, then you use resilient channel, tape, drywall. And so by using CLT, they're not only faster to assemble, but you don't have to go through all of that insulation process. And then the second building we did for them, they decided that they want to, rather than just use the floors, they wanted to use CLT elevator shafts and stairwells. So the second building, they shaved about another 3 weeks off the structure by using CLT for the cores of the building. One of the ways we're able to reduce the price of these buildings and the cost of these buildings is the companies that make the light wood frame panels for these buildings not only make those, but install them. They also install the Element 5 CLT floors and cores. And also what we're doing is we're starting to use more and more prefabricated components to complete these buildings. So now we're starting to use prefabricated stair cassettes. So before we put the next floor in here, the crane comes and drops these prefabricated stair cassettes into the stairwells, which are quickly fastened to the inside of these stairwells, and again, saving a tremendous amount of money. And it's one contractor that basically does the entire structure of the building, so you don't have different CMU block guys, working against the framers. So about 6 months ago, I hired an independent cost consulting company to do a comparative cost analysis of the most common structural alternatives that are used in the affordable housing sector. And here you'll see 8 of the most common structural alternatives. And they're ranked here in terms of total cost per square foot. This represents the total hard cost of construction. It doesn't look at things like the soft costs, like architectural fees and engineering fees. And it also ranks them by the speed of the assembly of construction. And so, firstly, I would take these numbers with a little bit of a grain of salt here, because the numbers will vary depending on whether it's union labor or non-union labor. It depends on the geographic location, whether it's in a rural situation or, an urban situation. But I think what's really important is understanding where this hybrid structure fits in within the overall range of prices. So if we go back to this building here, so this is the all mass timber building. So that is line item 4. So that is the fastest form of construction, because it's only one structural material used for the whole building, but it's not the cheapest form of construction. The cheapest form of construction is the all light wood frame building with no mass timber components whatsoever, but it's not the fastest form of construction. The one that we're promoting now is, to a large degree, is this hybrid structure. We think this is the ultimate in terms of building structure in the affordable housing sector. So this is line item 2. It's just slightly more expensive than the light wood frame option, but it's about 15 to 20% faster to construct. And we as a company are trying to find solutions to overcome the affordable housing crisis. And so the beauty of this solution is all of those components, all of these components are made in factories and assemble very quickly. So we can do about 80 of these buildings per year if we did nothing other than affordable housing. Many advantages to this form of construction. Firstly, it's cost competitive. Of the 14 projects we have won so far, we've won every one of those based on price. And we've won those up against all of the usual contenders, precast concrete, volumetric modular, ICF block. And so we know we have a very competitive solution in the market, very fast to construct. You saw how quickly the building went up and how quickly the project came together from beginning to end. We know we're creating healthier environments for occupants as well as healthy for the environment. We're able to produce those buildings in volume. We're helping to overcome the affordable housing crisis. We're using natural, renewable, sustainably harvested materials. Because of the way these buildings come together in a BIM environment where all of the major contractors and trades are working together in a 3D model, we're looking for opportunities to find synergy between everybody and to reduce clash detection. So because of that, there's much more cost and schedule predictability. You're less likely to get unforeseen charges at the end of the project because somebody forgot something that was important early on in the design. These are high performance buildings. Because of the thermal mass properties of wood, these buildings perform much better than traditionally constructed buildings. The life expectancy of one of these buildings is well over 100 years. These are really solid buildings. Typically, a building like this one here takes only 6 workers to assemble on site, whereas a concrete building would probably be in the neighborhood to 3 to 4 times that many employees working on site. A lot less off-site traffic. You don't have the concrete guys coming and going, so a lot less traffic, less construction noise and community disruption. And last but not least are the aesthetics. These are lovely buildings on the inside. So here you're seeing the exposed underside of the CLT panels, what the lobbies of these buildings look like, what the hallways of these buildings look like. When we speak to the people that occupy these buildings, like the people from YWCA, there's just a real connection. As humans, we feel naturally connected to these kinds of buildings. So there's a sense of peace and tranquility and safety and security in these buildings. So they're very well received by the people who live in them. We realized early on that with slight modifications to the floor plans of these buildings, we could proactively go after not only the affordable housing sector, but retirement living buildings, student residences, market rate housing, hotels, and many others. So essentially, this is the same structural solution that we can target each one of those. So, and so just 2 slides left. Just a little bit more information about Element 5. So since 2015, I think we've done over 400 projects. This is a small selection of the projects that we do. So it's not just about affordable housing. There's a full range of buildings that we do in this way. This is an early project we did. This is a fire hall in Oakville, and kind of cool. We've set this trend now to do fire halls in wood. And this particular one, we use what's called Shosugibon siding on the outside, which is another word for burnt wood siding. So it's a fire hall that uses burnt wood siding on the outside made out of wood. So we're now working on our 4th project, fire hall in Ontario. This is a 3-story hybrid structure. It's an office building in downtown Toronto. This is an absolutely beautiful glulam structure with curved glulam in it, and it's a healthcare access center for an Indigenous community in London, Ontario. Get into some of our larger projects now. This is one that's nearing completion. This is an 80,000 square foot office building for the Toronto Regional Conservation Authority. This one I'm really proud of. This is a daycare center in St. Thomas where our factory is. And this was kind of our way of contributing back to the community in which we have our factory. It's absolutely lovely on the inside. Starting to do a lot of buildings in the US now. 2/3 of our buildings we're exporting to the US. We probably have close to a dozen projects in Michigan. This is a veterinary clinic. This is a country club. This is an absolutely beautiful school for handicapped children primarily. And this is one we're currently building. It's a 250 unit student residence in downtown Toronto for the University of Toronto. So that's it. That concludes my presentation. And I'm open to questions if you have any.